In this video, I'll be helping you with the ALEKS problem type called drawing a reference triangle on the unit circle and using it to derive values of trigonometric functions, radians. In part A of this question, we're asked just to sketch theta equals -5 pi sixths, and then use that to find the lengths of the legs of the reference triangle, which are here called A and B. And once we have A and B, we'll also know the coordinates of the point P, which is that location on the unit circle. So we'll start by locating theta equals -5 pi sixths. Since we have negative radians, we know we'll be moving this way around the unit circle. Beginning at 0, our special angles here halfway around would be -pi. Halfway between 0 and -pi would be -pi halves. And then just labeling the other special angles in this area, we have multiples of -pi fourths. The first one being in the middle here, -pi fourths. Multiples would be 2 pi fourths, which we already have indicated here, pi halves. Next would be -3 pi fourths. And since the angle we're looking for is -5 pi sixths, that will actually come in once we look at our multiples of -pi sixths. The next multiple being -2 pi sixths, which simplifies to -pi thirds. Then -3 pi sixths is again pi halves. -4 pi sixths would be here. That simplifies to -2 pi thirds. And then -5 pi sixths would be this angle. So since this is our -5 pi sixths, we've located our reference angle. So the legs of our triangle will be shown here, where A is the length on the x-axis and B is the length on the y-axis. And you can also see here that A will be the x-coordinate of this point and B will be the y-coordinate. So from here, I'm going to look again at our pattern, cleaning things up a bit. We're working here in this third quadrant, and we know that the coordinates of this point are -1, 0, and the coordinates here are 0, -1. And we've talked before about the pattern moving along these special angles that are indicated here with the tick marks, being a pattern of the square root of 4, 3, 2, 1 over 2, with 0 being the square root of 0 over 2. So our next x-coordinate, since we're moving to the left, is -square root of 1 over 2, or -1/2 as the x-coordinate, then -square root of 2 over 2. Next is the angle we're looking at here, which is -square root of 3 over 2. And then, of course, -square root of 4 over 2 is our -1. Going in the opposite direction for the y's, we're moving from 0 to -1. So 0 being the square root of 0 over 2. Next is -square root of 1 over 2, which is 1/2. Then -square root of 2 over 2, -square root of 3 over 2, and -square root of 4 over 2 is our -1. So I've labeled here all of the special angle values for quadrant 3, but you can see we're only interested in this one. So we can see here that the coordinates at this terminal point here, P, are an x value of -square root of 3 over 2 and a y value of -1/2. So we found the coordinates of this point. A and B here are just distances. And with A being the distance along the x-axis, we would just drop the negative. The length of A is the square root of 3 over 2, just dropping the negative from our x-coordinate. It's the length along the x-axis here on our triangle. B is the length along the y-axis. So again, we'll just drop the negative on our y value since it's just a distance. So the length of B is a 1/2. And from here we can move to part B where we're asked for cosine, cotangent, and secant. We already have the cosine, that's just the x value, negative square root of 3 over 2. We also have the sine, which is negative 1/2. So from here, we can find any of the other trigonometric functions. We were asked for cosine, so we already have that listed here, negative square root of 3 over 2. Next, we have cotangent, which is defined as the cosine over the sine. So in this example, cosine is negative square root of 3 over 2 over sine, which is negative 1/2. Simplifying here, I'll turn this into multiplication by taking the reciprocal on the bottom to negative 2 over 1. The negatives cancel, the 2's will cancel, the negatives will cancel. We're left with the square root of 3 over 1, or just the square root of 3. So we have the cotangent. Lastly, we're asked for the secant, and we know that secant is defined as 1 over the cosine, and since our cosine is the negative square root of 3 over 2, this is 1 over the negative square root of 3 over 2, or negative 2 over the square root of 3 when we take that reciprocal. We should rationalize this denominator, multiplying the top and bottom by the square root of 3 to give us negative 2 square roots of 3 over 3. So this is our secant. And at this point, we found all of the information that was asked for.